Howdy. I've been pondering about sulfur and auroral precipitation and auroral displays over volcanic activity or areas with volcanic activity, and hence Iceland and stuff like that. And this somehow brought a thought to my mind which could be at least interesting, I think, to some. Here is the Finnish copper playlist. And as the title goes, Finnish copper might have its origin on Venus or from the interaction with it. In other words, the stuff here, or much of the stuff, didn't erupt from volcanoes from underneath or some similar processes, geothermal activity. No, they came from above. And if you go to read up about ancient stories about auroras, it doesn't matter actually where you go. And of course, you need the story about auroral display. Many ancient people, they are afraid of them. They don't have good associations to auroras. They fear them. Nowadays, people pay a lot of money in order to come here to Finland and be in awe about the very beautiful auroral display. Yeah, it was so beautiful, and yeah, no fear. Why did the ancients fear them? There must be a very good reason for that. Like some ancient stories in Finland, they tell about if there's an auroral display and you have to go outside, wear a hat. And if you go outside and there's an auroral display, talk silent. Don't upset the auroras. Because they could come down and kill you. So this made me think about Earth's increasing vulnerability to space weather because of our Earth's magnetic field is weakening, changing. And going over to space weather live, for example, we can see stuff like the KP index, real-time solar wind. We have the speed, we have the density. We have the interplanetary magnetic field and the BC index. The auroral oval, the hemispheric power and disturbance time index, and magnetometers. And it seems there has been something a little bit going on recently. But one thing you somehow, or I couldn't find anywhere, if there's anyone who knows if there's some satellite or whatever which is measuring the solar wind, or CMEs in special, measuring what they are made of, tell me. I would be very interested in to go and take a look at that. And it's not that people will know what's in those coronal mass ejections, because you can find papers about that. Composition of coronal mass ejections, the Astrophysical Journal, 2016. We analyzed the physical origin of plasmas that are ejected from the solar corona. To address this issue, we perform a comprehensive analysis of the elemental composition of interplanetary coronal mass ejections, ICMEs, using recently released elemental composition data for iron, manganese, silica, sulfur, calcium, nitrogen, I don't know what an E is, and probably helium, compared to oxygen and helium. But there is sulfur. As I have been writing about in my recent paper, but I don't make a really long video now. But anyway, the relationship between copper and sulfur. You can check out the playlist. Let's scroll down a bit. And after having scrolling around a bit and endured some noise here, here you can find the sulfur. And it has variations, let's say like that. Like I tried maybe, I don't know if I made that video or I made once a video which I then deleted where I have been talking basically about the same stuff. But anyway, yeah, you don't really see those elemental compositions anywhere. No one is talking about what's the CME actually made of. You know, they are talking about the density, the speed, and stuff like that, but it's a coronal mass ejection, which has to make us think that what's the mass then? There's material. Because I think the mass or the matter matters. It might have a big difference. I mean, the composition of the CME on the impact. Because sometimes you read that, yeah, there has been a strong CME and blah, 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 and nothing happens. And sometimes there's a weak CME and everybody's surprised of how badly it impacted. And I have been pondering about this. And now I'm searching for something here. There, I couldn't find it, but let's go with this one, because that's also interesting. The composition of elements with intermediate FIP, what was it again? Some ionization process. Behave differently. Sulfur oxygen shows enhancements with an ordering identical to the metals, but with smaller enhancements and comparatively large error bars. Somewhere they were saying they actually don't really know where's the sulfur from and stuff like that. But anyway, the thing is that the origin, yeah, it was at the end. The origin of sulfur, calcium, nitrogen, and oxygen depletions, on the other hand, is far from clear, and it's a subject of a great deal of ongoing research. Okay. And hopefully you are familiar with the Sapphire project, the electrical sun. That's why we have to go and look for this one welding paper I found some time ago. Oscillatory Maragoni flow, a fundamental study by conduction mode laser spot welding. Because through Maragoni flow, a surface active agent can affect not only the weld pool depth, but also the pool surface deformation, pool surface oscillation, and ripple formation. A surface active agent, which is in this case sulfur. And if we see the sun as an electrical body, as Earth is a capacitor, then we take sulfur into the whole circuitry. And I just want to show you this. I have been showing this. Sulfur effect on ripple formation and penetration. On the left side, there's a little sulfur. On the right side, there's a bit more sulfur. So the pattern is different. And that's from above. If we look at this from the side, this is a low sulfur content. This is a high sulfur content. So my question, what I have been pondering about for a while now, is not only how much does the solar wind or however you want to call it, the pressure chamber. The solar wind, or CMEs, coronal mass ejections, differentiate in their material composition. Do we have sometimes very much sulfur and, very weak, slow, low density? The CME has huge impacts on Earth's magnetic field and stuff like that because it just seems to penetrate. This is just one thing I have been thinking about, that maybe there should be a little bit more focus on the actual composition of coronal mass ejections, not just the speed density and stuff like that. Like the actual matter, the material. What is it? Is there how much iron, how much sulfur, how much aluminium? And if there's more than an average of some of these, do they have greater impacts on Earth? Obviously, at least sulfur has great impacts in welding processes, which are electrical in nature, as is the sun and Earth. So, somehow I would expect something similar happening in space too. And on the other hand, if you turn it around and you have a volcano which is spewing SO2 out, sulfur dioxide, gases, Grindavik, for example, at the moment. And this goes into the atmosphere. Is there any possibility that there could be more energy flowing because of the sulfur? Because it seems to make connections which are going very deep. There seems to be something very special about the sulfur. I have no idea yet what it is. Maybe one day I figure out, or someone else can just tell me because he knew it all the time, or she. You know? And it's probably not only sulfur. The aluminium is also very interesting. CMEs, coronal mass ejections, and somehow no one cares what they are made of, even though they carry the word matter in the name. It's the mass. Yeah, I've been thinking about this, and now I just shared this unfinished thought with you because it just had to come out in a way. I had to get rid of that. Yeah, this was my second attempt. I don't know. It's a little bit hard to explain the whole thing. Effect on sulfur content of 304 stainless steel on ripple formation and penetration depth of spot welds. Lightning discharges from the sky. They are basically like welding arcs too. Yeah. What about then the volcanic lightning and the relationship to sulfur? Yeah, it's all very interesting. If anybody knows something you think I should know, tell me. If you know the answer to any of my questions, tell me. If you can show me something that I'm totally off topic and talking crap and stuff like that, tell me. I am eager to learn. I really would like to know, and I really don't want to waste my time with following wrong clues and stuff like that. Anyway, thanks.